All right, let's start this. Let's try this again. Hopefully you can hear me this time. I can see my mic little bar is moving this time, so I actually have a microphone, and you can, hopefully you can hear audio. I can see myself. All right. Yeah, good. Thank you. All right. So anyway, we finished Hello World. We finished primitives last time, and now we're looking at custom types. And so we've got, let's go back and have a look. Custom types are structs and enums. Not a whole lot going on here. And then we have const and static keywords that can create constants. Yay, we can create constants. Enums are kind of like, old school enums. And structures, I guess, are the only thing we've got to group things together. All right, so let's see. Structures. So we've got tuple structs. We've used the tuple structs before without really knowing it. I think when we were looking at tuples, and down here, I think it was down here somewhere, we gave this tuple, where did it go? Oh, here, matrix. Struct matrix that. So that was a tuple struct there with this matrix. And without really telling us what we were doing, that's what they did. We've got this, okay, so that's that. The classic C structs. So, hey, hopefully, so that's the ones like you give properties names inside structures. So that's pretty much every programming language allows you to do that. And then we've got unit structs, which are fieldless, and may be useful for something which we'll deal with later. So we've got this struct person. We've got struct unit, that's the unit struct. We've got the tuple struct, like the other one. And then like the matrix. And then we've got the XY, just like person here, where we've got named fields. Looks like the standard here is to use lowercase for the names of properties in the object. Which should be a little different. So we've got rectangle here, also top left, and you can use point. So without being able to use objects inside objects or structs inside structs, we really wouldn't be able to build anything really complicated out of simple things. And then we've got this thing here, which is let name equals string from Peter. Now, why not just a string? We did this before, and we just assigned it a string. But here, we're using string from and then the string. So is this not really a string that we have to convert it into a string? Interesting. Age 27, person name. And how does it define? Name is string, uppercase S string. Interesting. Okay. I'm going to play around with that a little bit. So let's just grab this code and pop over here. And we've got I've created something, a structures thing. So let me file, open, folder, Rust, structures. Whoops, yeah. Actually, I needed to go back one. Just that one, select folder. Okay, and then we've got that, and there's our main, and we're going to take this and Control V, and there we go. And let's just run this to see what happens. And we have some output. And person named Peter, age 27, pointer coordinates, second point, pair contains. Okay. All right, we'll have a look at those. So the first question is, what's this thing about? Why do we have to do string from? So let me just put Joe here and see what happens. Oh, that's interesting. This is underlined. What does it say? Expected string found ampersand stir. Okay. So, in fact, this was never a string. It's an ampersand stir. I'm not sure what the difference is between the two, but I guess we'll find that out at some point in the future. And then print debug Peter. And so there's the debug output, the name of the class, and then curly brackets, and then all the properties. So that's the debug out. And then we've got a point at 10.3 and 0.4, and then we're going to print it, but we're extracting x and y, so we get this, and there's the brackets, point coordinates. Yeah, okay, so that's fine. Make a new point by using struct update syntax to use the fields of our other one. So, oh, this is interesting. So bottom right is point x 5.2 point. Bottom right. Okay. That's interesting. So what's this do? Dot point. Because we're taking this and what is it doing? Make a new point by using struct update syntax to use the fields of our other one. Okay. Oh, is it doing something like... All right, well, let's try this. So if I get rid of this and I run this, so let's save that. So that works. It doesn't complain. So if I run this, then this one ends up being 10.3 and 0.4. So it's using both of the values from the original struct point to populate bottom right. But if when I had it before, I had pre-populated 5.2. So when I ran this, I guess it said, hey, 5.2 is already populated. So really what you want me to do with this is you want me to populate, oh, don't do that. You want me to populate the other one that I didn't populate, that I didn't specify. So that means if I say y, whoops, oh, come on back here. Y 5.2, then if I run this again, then there you go. So y became 5.2 and x was filled in by the other. Well, that's cool. That's kind of fun to do that. We can say, hey, let me specify what I want to specify, and then everything else just grab it from here. I kind of like that. That's fun. Okay, and then second point, bottom right x, bottom right y. Yeah. So okay, that give me that. Okay, and then we have destructure the point using a let binding. Let point x, y, x left edge. Oh, this is fun. What's going on here? So we've got x colon left edge colon, or not colon, but that's in white. So that's the telling us what's implied, that it's a float 32. And I guess it's a float 32 because this was a float 32 to start. So what's it doing here? So it's saying left edge, top edge. Left edge, top edge. So where did left edge and top edge come from? Are those the new names for the thing? Because I never defined anything called left edge. This is the first definition of something called left edge. And the first one of top edge. So is it trying to tell me, because it's saying destructure, so that usually implies, so where, pair, yeah, integer decimal pair. I don't know what's going on here. they did it, but then they didn't actually use this. So I don't really understand what the point is of the left edge, top edge thing. Rectangle, top left point. Well, okay, so let's do this. Let's yeah, I don't know. What is this? Is this a variable? Is this a... Huh. Alright. I'm deeply puzzled by this. Alright, so what are they trying to say here? We've got something called left edge that we are assigning to X, and top edge that we're assigning to Y. But where did they... But, oh, the values would have come from point. But then, now we refer to them by their names, left edge and top edge. What if we bind a value to a variable? The primary use of let keyword is in let statements, which use a new set of variables through the current scope as given by a pattern. Oh, new variables. Okay, we are getting that kind of behavior. So let part 1, part 2 for second. Struct example AB. Okay. The pattern is more commonly a single variable, which means no pattern matching is done. Variables in Rust are immutable by default, require the mute keyword to make mutable. Multiple variables can be defined in the same name, known as shadowing. Okay. Alright, so then what's happening is we're creating a variable called left edge and a variable called top edge, which are going to be assigned to the X and Y values of point. So if I comment this out, then and I save this, then left edge and top edge are no longer defined. Okay, fair enough. So now if I say let bracket left edge, top edge equals point.x, point.y. Can I do that? Yes, I can. Okay, so I'm using the tuple approach now that we learned before, and this looks like it would also work. So then I can take the two values from the array, convert them into a tuple, and then assign that tuple to this tuple, and now give those two properties different names, which I can then use down here. So I suspect this, which I commented out, is a behavior that is similar to this. Okay, so let's or actually, let me just run this just to make sure that it not just compiles but runs properly. Yeah, 10.3, 5.2, because right, 5.2 point, right, because y was 5.2, so it populated the x with 10.3, yep, and then I moved left edge and top edge, and so let's just set a breakpoint here just to make sure, and we'll do a debug. Run debug. Okay. Sure. Okay, and then we'll save that because that's cool. All right, and so now if I hover over left edge, 10.3, and 4.0. Really? X is 10.3. Wow. 10.3, 4.0. Interesting. But notice, I just want to point something out. It's not 10.3, it's 10.3000002. This is the issue with floating point numbers, is you get rounding issues. And there's an example of rounding issues with floating point numbers. And, you know, if you're doing scientific calculations like Celsius to Fahrenheit conversion or something like that, it's not a big deal. But don't try to use floating point numbers when you're doing accounting for Apple with their trillions of dollars, because you'll get rounding errors. Things will not be happy. Okay. So then if I step over. Okay. So let's have a look at a rectangle. And rectangle is 5.19999981, which is 5.2, 4.6, 4.0006. Yeah, so we've got all sorts of little rounding issues because 5.2 can't actually be expressed apparently exactly in the amount we have. Now, if we did, so let's just stop this. If we change this to be F64, oh, come on. And let's see, I think that's all we had to do, because everything else is just going to automatically convert to be F64 for us. So if we run that, this time, what's going on here? Terminal. Oh, here, back to here. Run. There we are, we're at our breakpoint. So if we have a look at rectangle this time, hello, where are you? Where are you, rectangle? Oh, we haven't assigned it yet. All right, F10, step over, there's rectangle. We have a look. Actually, we just hover over rectangle. It'll be easier to look at it here. Now, we still have a rounding error, but a lot further away. And then it's 10.4 and lots of zeros. Then 5.2 and lots of zeros before the 2. Right, so this is going to give us a more accurate result by going F64 instead of F32. But F32 is really just, you know, okay for, but you wouldn't want to use it for a moon landing, you know, especially if you were aiming for a particular spot on the moon. You know, if you just wanted to hit somewhere on the moon, probably F32 is okay, but not if you want to be more accurate. Anyway, so yeah, so there's that. Let's see what else we have here. So after we've done that, oh boy, so let's throw that away. Let's toss that away. Let's toss that one away. We're back to here. Okay, so let's have a look, and what's after this. So let unit, okay, initiate a unit struct. Okay, cool, we did it. And that's all we do with it. So I still don't know what to do with unit, because we don't really do anything with unit. But pair, right, with that tuple struct, we've kind of familiar with that, so we don't. But again, the weird thing about the tuple struct is the fact that you have to refer to the elements like this, which is kind of ugly. So, all right, there we go. So that's not bad. We've got some stuff going around here, some floating point. We've learned this thing, which is cool, and we learned about string, which is not the same as ampersand stir, which is the default data type if you just type quotes around a word or words. Interesting. All right, enough of that. Let's move on. So let's pop back over here. let's have a look. What have we got? So that's structures. Are there anything? Oh, there's activities. Add a function rect area which calculates the area of a rectangle. Try using nested destructuring. Okay. Add a function square which takes a point and an F32 as arguments and returns a rectangle with its top left corner on the point and a width and height corresponding to the F32. Okay, sure. We'll do rect area. Calculates the area of a rectangle. All right. Let's we don't need that anymore. Let's give that a try. Where are you? Where'd you go? There you go. All right. So we want to put it outside main, and I guess it's fun rect area, and we're going to return. So it's a single arrow, I think. We're returning a F64, and we're going to take in a rectangle R. What's the problem here? Missing type for function parameter rust analyzer syntax quick fix. Rename to rectangle. Oh, is this? Oh, do I need to do it? Is that? Do I need to do it that way? Oh, yeah. Never mind. So used to doing it the other way around. I think that's correct. Yeah, I think that's correct. But we'll find out in a second. So if we want to find the area, what we need to do is we need to get the length of the sides. All right. So since we have top left and bottom right, then what we want is the top left to bottom left, and then the top left to top right, those lengths. So let's see. So the top left, or it's R, top left. So that one dot X. All right, so we want the X, and then we want the actually I think we want the top left will be, hopefully the top left is smaller, but we may just, you know what, we should just do the absolute value and then we don't have to worry about it. But R dot, but we'll assume that people do the right thing for now. So it would be bottom right dot X minus, and that would be let width equals, I do believe, right? So think about this again. So the bottom right's X, so the right hand side X, subtract the left hand side X. So the left in theory is smaller than the right, and so it'll be the right, which is the larger number, less left, which is the smaller number. Do the subtraction, get a number, okay? And then let height equals R dot bottom right dot Y minus, and again, we should be, the bottom right should be the larger number, the top should be the smaller number. So R dot top left dot Y. So then we have the larger Y minus the smaller Y, And so then we get a height. Now the thing is, that's not necessarily true. So we're going to end up with potentially a negative number. But it doesn't actually matter, because even if we ended up with a negative number, and so the area is the width times the height, right? So let area equals width times height. Or, since that's the thing we want to do, we could just do this, right? Because if we do this, right, then the way the functions worked, we can just, that's automatically a return value. We could have written the other way, which I wrote, because that's kind of the way I'm used to writing language. But in Rust, for whatever reason, we can do this, and that's the same thing as a return value. So now this width times height, that's going to be potentially a negative number if whoever entered the values for the rectangle did not follow the rules. And it doesn't actually matter, because whether it's negative or positive, the area is really the absolute value of these things, right? Because it doesn't, it didn't matter whether it was the larger minus the smaller or the smaller minus the larger. We're going to get the negative number, but we're going to get the same number but negative. And if they were both not following the rules, then that we've set out, then we'll have two negative numbers multiplying to each other, and it'll give us a positive number, and it'll be exactly correct. But if one of them is right, follows our rules, and one of them does not, then we'll end up with a negative number. We don't actually care, but we kind of do, because showing negative areas is kind of silly, right? It's just not what you expect. So we should probably figure out how to figure out the absolute value. So I wonder whether we can just say abs this. Unknown. No, we can't do that. So that's not going to work. Shoot. All right, so let's see. Let's go and do a little search. So let's say Rust language absolute value. How do I get the absolute value in Rust? Thank you, Stack Overflow. Num : abs. Use standard.number. It doesn't work. Nowadays, abs is a method in most number types. Value.abs. Oh, okay. All right. Okay. So we can do that. Let's give that a try. Where it is? There it is. So then this would be this dot abs. Oh, there it is. Look at it. It's right there. Yeah. There. Just that. All right. And then what we want to do is we will print here, print line absolute or area of rectangle equals curly brackets, comma, rect area underscore rectangle. Now, why are we using underscores in the lead here? Are we doing yet another type of because this underscore is a style of writing code where you make all your local variables start with underscore to distinguish them. But we've never done this before. So why are you suddenly throwing in an underscore as the lead character in a local variable? Just because it's fun? Like, I don't really get it. Anyway, so let's give this a try and see if we can't make this. Oh, run. Area of rectangle, 0. Well, that's not very good. All right, so let's set a breakpoint here and see what went wrong. All right. Okay, let's debug this one. Where'd you go? Debug. Okay, well, we're there. We don't need to be there. Continue. There we are. So R dot bottom right dot X 10.3. R dot top left dot X 10.3. Oh, well, that's why. Because basically the width excuse me, the width of a rectangle is 0. So hey, we got the right answer. So and y is what is y? 5.2 and 4. So really it doesn't matter. So let's fix that. Yeah, we substituted. All right, well, that's not what, doesn't matter what we do here. Okay, can we do this? So can we say the top left? So let's do -5. Can we do this? Oh, it's not going to let me do it. No, I'm assigning. Darn it. What's the problem? All right, let's stop this. Let's see. Maybe it's just complaining because I was debugging. Nope. Performs the subtraction operation. Cannot subtract integer from F64. Well, can you just convert it to an F64 for me? There we go. I have to say. That's a... All right, let's do it 5.0 F64. I wonder, if I say 5.0, will it... Oh, yeah. It's cool. It was 5. It said that's an integer. Can't subtract it from a floating point number. Well, you can, but okay, fine. But 5.0, oh, sure, I can coerce that into an F64 for you. All right. That's a little weird. All right. All right, let's run that. And area of the rectangle is 24, which makes sense because I made it to be 5 by well, this is 0.4 to 5.2, which is around 5, just under 5. And this is 10.3 subtracted 5, so it's 5.3. So it's 5.3 times, which is remarkable that it's 24 exactly. That doesn't seem right somehow. The likelihood that that's exactly 24 seems a little low to me. All right, let's, maybe I'm wrong, but let's just debug this just to make sure. Okay, fine, we're there. Cool, we're there. So let's just go step. So the width is, oh, there we go. The width is 5. The height is, the width is 5. Oh, it's 10.3 minus 5.3. Right. Oh, sure. That makes sense. So it's exactly 5. So 5 times 4.8, basically. So, yeah, that actually works. 24. Pretty much exactly. The actual... I wonder if I can hover over this and get it to do a calculation for me. No, I can't. It sometimes in like other programming languages we can wonder if I can, in the debug console, can I say width times height? No, width is not a valid command. No, can't do that. Okay, because sometimes in immediate mode you can actually type the current local variables and have it do a calculation for you. But what if I said equals width times height? Nope, that's not a valid command either. Okay, never mind. We won't be mucking with that. I don't know. Maybe there's a way of doing it, but don't see it. Width, height, yes, 4.8 times 5 gives you 24. So yeah, it actually works out, miraculously works out to be exactly an integer. Well, you know, within reason. Okay. And yeah, we didn't need the absolute value because both of these were positive, but that's okay. So let's stop that. All right. So, yes. I know. Underscore on unit, but not on pair. Yeah. Assign it to a variable and print. Yeah, I guess we could do that. We could give that a try. Because down here we can do let area equals rec area rectangle, and then we'll just go make this area. But if I set the breakpoint here, I can check what area is. All right, so let's save that and let's run this again. Run. Oh, not run. Debug. Okay, there. Let's get rid of this one. It's slowing me down, and I can get rid of this one now. That worked. Get here. Okay, area. So area is, where are you? Area. What the heck? Age, Peter, point, bottom right, left edge, top edge, rectangle. Where are you, area? Well, that's weird. Why isn't area here? What did I miss? Step. Oh, there's area. No, it actually comes out to 24 exactly. But it is an F64. So those rounding errors canceled out? Or something? I don't know, that's weird. I don't know what's up with that. But yeah, it's coming out to exactly 24. And not 24 point lots and lots of zeros 2 or anything, just 24. I wonder if it's the absolute value that does something funky with it. Oh, you think you could write it in the console? Doesn't include the variable in the debug console until after the line after the question mark. Yeah, maybe. I don't know. That was odd. Yeah, that area didn't show up until after I executed the next statement. It was like, yeah, until we did the print line. It said, oh, I don't need you to know what the thing is. But here, if I do the debug console, and maybe I can say print area. Yeah, there we go. Oh. All right. So now I can say, print rectangle? Yes, I can. Well, that's fun. Okay, this is good. So I need to say print and then the thing. So I probably could have said print width times height, and it would have given me the answer too. But what's weird, what's weird is that all of this, oh yeah, it's an F32, blah, blah, blah. And then you get down to here and you go, no, it's a double. I don't know who's formatting the output of the debug area, but double is not what you call it in Rust. Double is what you call it in C# and Java, and well, not JavaScript, but in Java. Yeah, so something fun going on there. Okay, but yeah, but double is F64. That's the same thing. But we have structures, rectangle, top, left, right, and then some weird formatting that happened over here with a blank line. Okay, so this is cool. I like this. Going to the debug console and doing this. I learned something new here. Because sometimes you want to do little, sorry, let's see. If I say print area times 2. Not a Rust type. Oh. Print area times 2.0. Not a Rust type. Nope, that didn't do it either. Bracket? Okay, let's try that. Print area times 2.0. Nope. So can't do math? Can print the things, or maybe I can't. No, but I should be able to do math. So let's see. If I say times 2.0 here, then that's okay. So let me stop that. Double area of rectangle. So let me just run that. Because if I can, yeah, double the area of the rectangle is 48. Okay, so it's doing the right thing. And so I can do math here, but it looks like I can't do math in the debug console. Sad. So limited usefulness, because that means I can't actually kind of in immediate mode try out calculations. I have to actually do it in the code. Yuck. All right. So then there was one other activity. Let's just go back and see what that other activity was here. It said add a function square, which takes a point and F32 as arguments and returns a rectangle with its top left corner on the point and a width and height corresponding to the F32. Okay, fair enough. Let's make something square. So I'll tap. Now, I wonder what he meant by try using nested destructuring. I mean, I don't think I did nested destructuring, whatever that was intended to mean. You back to the debug console. So okay, print. Oh shoot! I have to. Oh, please start a debug session to evaluate expressions. So expressions. That's interesting. All right, let's debug this. Get it going again. That we had the breakpoint. Now back in debug console, let's do a print area and rectangle. Okay. Or how about print area times underscore rectangle dot bottom right dot y. Not a Rust type. So the star is what's the times is what's causing the problem. Yeah. Print area times area. Not a Rust type. Print brackets area times area. Not a Rust type. You know, there may be an magic formula here, but we're not finding it. So whatever. I know. This is weird. That's strange because usually you can do that in immediate mode. You can do some simple calculations, but this is not parsing that for whatever reason. Okay, I'm not going to worry about it. We'll probably encounter this later and discover what we were doing wrong, but I think I've beat this particular horse to death already. Okay, so the last thing we wanted to do was create a square function. So function square, and we're going to take a point, p point, and length f. We're going to do it f64, even though it said e told us f32, and we're going to return a rectangle. Okay, and so then what are we going to do here? How do we do this? So I think, well, I guess I would do like a let r colon rectangle equals, so then it would be, so the point is the top left. So then the way we did that was we said top left colon point, right? So so it would be, how did it do that? It went rectangle colon rectangle equals rectangle curly brackets. Okay, so we don't need this rectangle because it'll fill it in for us. So we can do equals rectangle. I always want to type new, but I don't need to type new here. Rectangle top left colon p. Is it comma or is it semicolon? It's comma. No, wait a minute. Where'd it go? It's comma. And then bottom right is a point, and x is p dot x plus length, and y is p dot y plus length. Pretty sure that works. Yeah, something like that, right? And what's this? Or we need a semicolon. Why do we have spaces? Okay, format it. Oh, it's the dot for. Consider returning the local binding R. Okay, quick fix. Consider returning the local binding R. Yeah, I did consider it, but I thought you were going to quick fix it for me. Nope. So I guess what it's saying is, why are we complaining? Expected a struct found round brackets. What's that? It was the first line in the method line. It added it. Did I not add that? Implicitly returns brackets. Oh, I know, because return R. So it should be now happy. Nope. Oh yeah, now that's happy, but what's wrong with this? Move occurs because P has type point, which does not implement the copy trait. What? It assumed made assumptions about the return type. Yeah. So Didn't I add that? Or I guess I didn't. But I'm not sure why this, because I did want to return R. But this, but why is it happy with the X, but not happy with the Y? Use of moved value P. Value used here after move. After move? Oh. Okay. So I think what this is saying is that I have actually assigned this to top left. And now I'm trying to, okay, so let's see. If I say let width equal p dot x plus length, and let height equals p dot y plus length, and then I say width height. Now are you going to be happy? Yes. So what happened was, I think, I'm based on the error message, I think once I took this and put it there, I can no longer use it, modify it, because it was moved. Maybe I needed to make a copy of P to put it there, because I don't know. Am I reusing this memory location here, and now this is the owner of that memory location, and I can no longer manipulate it? Need more P. yeah, exactly. But when I did it before, so I did the math over here before I had assigned it, and then everything's cool. So yeah, maybe that's what I need to do. And then down here, I can say let square equals square point 1 1 comma 4, and then print line area of square equals curly brackets, and that would be rect area square. All right, let's try that. But there's something it doesn't like. What doesn't it like? Use a struct, curly brackets instead of round brackets, because I think I've made a tuple. No. Oh, and now what? Unexpected identifier. Do I need to say, right, because it's x colon 1, y colon 1. Okay. Save that. Oh, and now these need to be 0.0 and 0.0, and this length needs to be 0.0. Okay, and now run this. Area of square is 16. That makes sense because it's 4 by 4. All right. It's a 4 by 4, so its area should be 16. Cool. So that worked. This is a little funky, this whole business going on here with this height. I'm sure there's a way of making this more abbreviated, but I think for now we can do it this way. We can just pre-assign things. All right. So there we go. There's Can you make me a chat? Spam pods? Yeah, sure. I'll figure that out. Yeah, sure. We'll do that later. Okay, so that's it. This is the end of our adventures with structures. Let's see, what do we got next? Next is enums. So we'll play around with those next time. All right, talk to you later. Bye.